When working with ratios, it's very important to make sure you stick with all the key rules. First of all, what is a ratio? Well, it's just a comparison between quantities, but they must be the same kind in their units. So if we look at this example, we've got Tom's height was 169 centimetres and Laura's was 165 centimetres. So we can see that their units are the same, and therefore we can compare them in terms of being ratios. So Tom's height to Laura's height, we would write it like this. So there's Tom using the ratio symbol, and there's Laura, and that gives us 169 to 165. Now that can also be written as a fraction. So a ratio in fact is just another way of writing a fraction. 169, the first term is the numerator and the second term the denominator. And we leave it as an improper fraction. So that's exactly the same way, but leaving it like this is probably the best way in this case. Now let's have a look at Laura's height to Tom's height. Just reverses. So order is very important. So we put here Laura first, followed by Tom. And in the same way, the height would then be for Laura 165 and for Tom 169, which can also be written as a fraction. This time 165 is in the numerator because it came first, and 169 is in the denominator. So there's some important things to learn as you do these ratios. Let's go on to the next example. In order to do this though, the one thing that we stressed last time is that you can't change the order around. If you're writing 169 to 165, you can't reverse it and say that it's still true. A couple of bits of information we can write using colon notation, which is like this, or as a fraction. Ratios, there are no units in ratios, and also that ratios can be simplified. And we're going to do a little bit of this simplifying, but the main thing is to do this, you either multiply or divide all the terms in order to simplify down. So you can't just change one term, you must change both of them. So in this case, we've got some ratios that will definitely simplify down. So 24 to 18 turns out to be 4 to 3. And we would get this by dividing each term by 6. All right. Now, your calculator can do this. You can actually put this in your fraction key, 24 over 18, but you need to make sure that your answer comes out as an improper fraction. So your calculator will simplify these down for you. Let's try B, and you can go ahead and try these out. This time we've got 3 terms, 16 to 12 to 20. And if you look carefully, you should be able to see that the biggest number that can go into all of them is 4. And if we divide 16 by 4, we get 4. 12 divided by 4 is 3. And 20 divided by 4 is 5. So we've divided each term by 4. All right, now when we have a look at the next question, I'll just get my pen here again. We've got decimals in this particular question, 1.5 to 2.7. Now you're not actually allowed to have decimals in ratios. So in this particular case, we're going to have to multiply both sides by 10, if we do that, we get 15 on this side, and we get 27 on this side. And we do that by multiplying by 10. But if you have a careful look at the numbers as well, you can simplify from here. And so we can simplify this down to 5 to 9 by dividing each term by 3. So get rid of the decimals first of all, and then simplify down if possible. And your calculator will always help you with this one. Let's try D. Here's another situation where you're actually not allowed to have fractions or decimals in your ratios. So we've got to fix this somehow. Now, probably the best thing to do first of all is to change this fraction here into an improper fraction. So 4 ones are 4, 7 over 4 to 2 over 3. So that's how we do that. Now, you'll notice that if we multiply both sides by 12, we're going to get rid of these fractions here. So that's what we're going to do. We're going to take 12 times by the left-hand side, 7 over 4, and we're going to multiply 12 by 2 over 3. And when you calculate, cancel these out, you'll notice that 4 goes into 4 once, cancels out with 12. That gives you 3, and 3 times 7 is 21. And 3 goes into 12 4 times, and 4 times 2 is 8, 21 to 8. So you're actually multiplying by 12 just to get rid of those fractions, and that works every time as well. All right, so what I'm going to do is I'm just going to make a little bit more space for this last one, and then we'll do the next example. But let's just move this down a fraction. That's good. And let's have a look at E. So I'll just once again move that up so we're in the frame. There we go. And here goes E. We've got 85 centimetres and we've got 1.2 metres. Now, as we said before, ratios are not allowed to be expressed in different units. So we have to change one of these. So we're going to convert them, I think, to centimetres would be best. So we'll have 85 centimetres here. And if I times 100 by this one here, that will change that to centimetres. So 100 will move that to 120 centimetres. Now, you drop the centimetres because you don't express them as units. You don't express the units in the ratios, 85 to 120. And then you can simplify this down as best you can, which will be 17 to 24. So if we divide by 5, you'll actually get that answer there, 17 to 24. And remember, your calculator will help you to do this. All right, let's keep going through these ratio questions. Very important to look at the variety of questions that you can get with these. And I'll create a little more space here as well because these are a bit cramped up. So we'll take this one here and move it down a little. There we go. All right, so express in the form n to 1. What that means is this number here has got to become a 1, and this number here has got to become a 1 for this to work. All right, so in order to do this properly, let's have a look at the ratio as it is. 25 to 10. Now, if I divide both sides by 10, I'll get an answer. So if I divide this by 10, that becomes 1, which is what I want, but I've actually got to write that divide by 10 as well. Now, this is one situation where you can actually have a decimal because what you're doing is you're putting it to a unit value of 1. So this is like 2.5 to 1, almost like a scale on a map or something like that. So you are allowed to have decimals when you bring it down to a unit value on the right-hand side because it's not always possible to have a whole number on this side when you've got a 1 on this side here. If you have a look at B, you're going to have the same situation. You've got 16 to 24. So what we're going to do is we're actually going to take that and divide both sides by 24 in order to make 24 into a 1. So we know that that side is going to be 1, 24 divided by 24. And this side over here, if you simplify it down to a fraction, you could write it as 2/3 to 1, but it's clear that it's not going to round very nicely to, so it's going to be a recurring decimal, so we would have to write 2/3 as 0.6 recurring to 1 in order to be accurate. I guess we could round this off and that would be fine. All right, so, but you'd need to say that it was rounded. Okay, in the next question, we've got some practical problem-solving type questions. The ratio of the number of boys to girls in a school is 7 to 6, and we want to know if there are 354 girls in the school, how many boys must there be? Well, let's write down our facts. Boys to girls. We know that that's 7 to 6. We also know that for boys, to girls, we would have boys not knowing what they are to 354. That actually has to simplify down to that ratio. So we know that 354 must match up with 6, so boys have got to match up with 7. So what do we do here? Well, look, the best thing to do is to write this as a fraction. Boys over 354 is equal to 7 over 6. So that's in fraction form, and therefore if you rearrange that, the boys, or the number of boys, must be equal to, now we're going to multiply 354 on both sides, and 7 over 6 times 354 is 413, which means there must be 413 boys in this school compared to the 354 girls. Just a couple more to finish off with. The same question, or this is sort of a reverse question, it says the ratio of boys to girls in a school is 8 to 7. So we've got to find out if there are 264 boys in the school, how many girls are there? Similar sort of question. So we write down that the boys to girls is equal to 8 to 7. And it means that if we write number of boys in this case, it's going to be at the top. See, 264 to girls, so we'll write that down. It's got to be equal to 8 to 7. So how do we write this? Well, it's perfectly all right to write the fraction with the girls at the top or in the numerator and the boys in the denominator, as long as you make the other side do exactly the same thing as well. So that would be 7 over 8. And in this particular case, when I multiply 264 by 264, working this out, I get the number of girls must be equal to 7/8 of 264, which is 231. You can check that on your calculator. And the last example we're going to look at for ratios, is a practical one where there's $24,000 worth of inheritance and it's got to be divided between two people in a certain ratio. How much will they receive? Well, we can work out how many parts are needed. So the number of parts that it's got to be divided into is equal to 2 plus 3, which is equal to 5 parts. So 5 parts, if you like, is worth $24,000. So Sam must be linked to 2 parts because he comes first, and Jamie must be getting 3 parts because he's second in the order. So order always counts. So what does Sam receive? Sam would receive 2/5, because 2 out of 5, 2/5 of the $24,000. So he would get $9,600. And Jamie obviously is going to receive more. He gets 3/5 of the total. So that's 3/5 of $24,000. And if you use a calculator to find that, that's $14,400.